So, welcome all. Um, this is my next video on parsing. So, this is a important topic of natural language processing. But because as we know, we have different steps in natural language processing. So, this parsing is basically it's related to the structure of sentence rather than the meaning of sentences. So here in this part, in parsing, we just care about the structure of sentences, whether the sentences are structurally correct or not. So, as you must have did parsing in compiler, or you may have did in theory of computation, parsing is also there in artificial intelligence. So this all is same kind of parsing we'll be doing in natural language processing, where we are checking the structure about the sentence. So coming to the part, what is parsing actually? Parsing is breaking down your sentence into the grammatical component that may be noun or verb or object, etc. So we are, as I said, we are concerned here about the syntax rather than the meaning of the sentence or how the different words are related to each other. So, machine wants to know whether the sentence is structurally correct or not. So, let's say we have a sentence, all the morning flight from Denver to Tampa, leaving before 10. So, what I can say, every sentence is made up of, it is made up of some, we have the determinant, but here we have a predeterminant. So it is predeterminate. Then we have a noun phrase. Later on, we have a noun phrase. Look, noun and noun phrase are two different things. Noun basically consider one word, one single word. So this is for one word, whereas noun phrase, when I say, it is component of noun and preposition or noun or something. So it is combination of two things. I would say it is combination of two things, two or more things. So like when I say it is a noun phrase, so this noun phrase consists of predeterminate and the noun phrase. Then this noun phrase consists of a determiner and the nominant. This is what this is your nominal. So nominal के अंदर we have nominal and we have graduative verb phrase. Then this verb phrase is like we are having leaving before 10. So this leaving before 10 goes to this verb phrase. Then again my nominal is divided into another nominal. This nominal consists of nominal and the verb phrase, preposition phrase. So to Tampa is my preposition phrase. Again, this is nominal and the preposition phrase. This preposition phrase consists of from Denver, and this nominal consists of again one nominal and one noun, and this nominal again consists of noun. And then this noun is morning and this noun is a flight. Okay, so likewise, if all the components are correct, all the non-terminals, I'll discuss what is non-terminal and what is terminal. All the non-terminals satisfied, so then I will say my sentence is structurally correct. So the steps for parsing is you can input a sentence. So once you input the sentence, it is a raw sentence, it is raw natural language sentence. Then the sentence will be tokenized into different words, and for every word we'll associate a part of speech. We'll do the part of speech tagging. So like I have a sentence, the cat sat on the mat. So the cat, the is a determiner, cat is a noun, sat is a verb, on is a preposition, the is a determiner, and mat is noun. So the syntactic parsing, this is called building a parse tree. We are making a parse tree, and based on the relationship between the words. This is just a fun fact. I want to. I have not included my picture in any of my videos, so I have included here. You can see me. So the parsing can be done by two ways. One is the top-down approach, another one is the bottom-up approach. The top-down approach in Python, it is defined by the recursive descent parser, and bottom-up approach is defined as shift reduce parser in Python. So I'll cover both of this in this lecture. So for the top-down approach, as I said, it is recursive descent parser. So within the NLTK toolkit, you can find it. You can call this function RD parser in the NLTK toolkit. And once you call this function, just you write these two lines, you'll get this pop-up window, and inside this window you'll get some examples as well. So this is first example you'll get, uh, like you'll be getting this is what is my grammar given here. So there are different sentences. Sentences are normally, it is made up of the noun phrase and the verb phrase. Verb phrase are generally consist of determiner, noun, and the preposition phrase. Please mind it, the preposition, verb phrase, noun phrase, these are the components of multiple different components. Whereas determiner, noun, and verb, they are the single words. Okay. So the noun phrase can be the determiner and noun. Likewise, you can define several rules. And as you see, the noun can be man, their noun can be park. So there are many possibilities for noun. There are many possibilities for verbs. There's many possibility for the preposition. So now I start making a past tree, and this past tree, because I'm considering the sentence as a whole. So my first I'll break my sentence into the noun phrase and the verb phrase, because we have one single rule for this sentence. There's no multiple rules for the sentence. So for sentence, we'll just try first NP and VP. So my sentence is divided into noun phrase and the verb phrase. Then noun phrase will be divided into three. Noun phrase, because for the noun phrase we have two clauses, and by default in computers it will go top to bottom and left to right. So noun phrase will be having the determiner, noun, and the preposition. So once it will go for the determiner, noun, and preposition, and as I said, the determiner and noun is the words. So once it will get a determiner, so what happens is the sentence will be broken into noun phrase and the verb phrase. Then this noun phrase will be divided into three, that is determiner, noun, and the preposition phrase. So for the preposition phrase, we have another rule. But for the determiner and noun, if you see the determiner and noun, we are having the and a. So first it will substitute the, okay. Then for the noun, there are these many possibilities. The first thing it will be substituting is the men, okay. Then next it will check the men, then as the preposition phase. So for the preposition, what we have is the preposition phase. It is preposition and the noun phrase. Then it will check for the preposition. Next preposition is in, and then we are having a noun phrase. So noun phrase again, I can have again. It may be a determiner. It may be determiner, noun, and preposition. So once the my compiler is not able to maintain, like the as determiner is already done. Then we have the A is a determiner. Next noun we are having is the park. But now, if we see, this is not matching with my sentence. My sentence is the dog saw a man. So it is not finding the appropriate words what is available in my sentence. So this the NP will roll back. So we'll be having backtracking here. And after doing the backtracking, the next rule that follows, that is NP goes to determiner and noun. So once it will go for NP goes to determiner and noun, then it will find the appropriate determiner, that is then, and the next noun, matching noun is the dog. It will try for all nouns, first man, then park, then dog. So dog will be fine as matching. So dog will be substituted here. Then the verb phrase के लिए again we have three possibilities. So it will try all three possibilities, but the first possibility it will fail. For the second possibility, it will be successful. Your parser will be successful. You can try executing in Python. Once you execute in Python, you'll get to know how it is working. So this for the second one, it will be successful. So it will find verb as saw, verb as saw. It will be failed. Then saw will be correct. Next, there will be a noun phrase, and noun phrase again we are having for the noun phrase. The first rule is the determiner, noun, and the preposition. So here determiner, noun, and preposition satisfies because my sentence is a man in the park. So this in the park will go in the preposition phase. A man will go in the determiner and noun. So there is lots of backtracking here. So once you execute in Python using the NLTK toolkit, you can find the all backtracking. And here it is the options. You can check it stepwise, or you can go for the auto step, and you can expand or you can match. So the with backtracking, this kind of structure will be found. Once my tree is created from top to bottom, so this is called my top-down approach. Once my tree is created from top to bottom, this is my top-down approach. I can modify my sentence. So by using the edit, using this edit option, going this edit option, you can edit your sentence, and you can change your sentence. So once you change your sentence, again another parse tree will be created corresponding to the new sentence. Or if the compilers, sorry, if the recur recursive descent parser is not able to uh, complete the tree corresponding to the sentence, then your sentence is fine incorrect. Okay. So you can go to the edit option. You can edit the grammar and you can edit the text. There's two options. You can edit the grammar, you can edit the text. If you go for the edit grammar, you'll your this box will be active. You can add rules here. Or if you choose the edit text, then the text box will be open and you can provide your new sentence. If the parser is not able to complete your sentence, then your sentence is structurally wrong. Okay. So here it is, the grammar editor. If once you go to for the edit grammar, you are able to add new rules here, new production rules. This text box, checkbox will open. Another is the bottom up approach. This one is my bottom up approach. So if you go for NLTK app, is SR parser. SR parser is for the bottom up approach, and this is the output of my previous parser. How my parse tree is being formed. So please don't confuse. This is the output of output of previous parser. Previous parser. Uh, that is RD parser. That is my RD parser. So this is the output of RD parser. And for the bottom approach, you can use this command. If you use this command, it will go for the bottom up approach. In the case of bottom up approach, first the sentence will be considered as um, it is as tokens. Token is each word present in the sentence. So corresponding to each word, now it will start matching from right to left rather than the left to right. My rules will be matched from right to left. So what I have is my. So for this my, it will associate a determiner. Then for dog, there is a noun. It is N. So now it will check the appropriate rule corresponding to determiner and noun. So corresponding to determiner and noun, I can say this is my noun phrase. Then saw. Next we have saw. Saw is a verb. Saw is a verb. A is again is a determiner. Men is a noun. In is a preposition. Then the is a determiner. Then park is noun again. With is a preposition. A is a determiner. And last, the statue I have is the noun. So now I start combining. So if you say if there is a rule for verb and the noun phrase, yes, there is a rule for verb and noun phrase. But the thing is, we have first verb, then the noun phrase. So I cannot combine these two. For this determiner and noun, again we have for the determiner and noun. If we check determiner and noun, I can make this NP. Now, with combining with this verb and the noun phrase, I'll get a verb phrase. This is my verb phrase. Combining this, you have verb and noun, you can make this as verb phrase. Then we have preposition, determiner, and the noun. So preposition and verb phrase. We can check the preposition and the noun phrase. So these two can be made as the noun phrase. Then preposition and the noun phrase. Combining this preposition and noun phrase, this gives me a preposition phrase. Then preposition and the verb phrase. Verb phrase and the preposition, this gives me another verb phrase. This gives me another verb phrase. Then next we have is the determiner as noun. Then this will be the noun phrase. Then preposition, noun phrase. This gives me a preposition phrase. Combining the verb phrase and the preposition phrase, this gives me a verb phrase. And combining last, I have the NP plus VP. Combining these two, this will give me a sentence. So if I'm able to complete the sentence, if I can come up to one single root level, so I can find one sentence, then my sentence is structurally correct. So this shift reduce, this is your shift reduce parser. This shift reduce parser gives me a bottom up approach. This is my bottom up approach. So if I'm going from word level to the sentence level, that is my bottom up approach. Or if I'm going from sentence level to the word level, that is my top down approach. So you can check your stack. This is showing you the stack. Eh, there are certain pros and cons for the top down and bottom up both. So the pros for the top-down parsing, it don't explore the tree that is not rooted as S. So if we don't have one single root as S, then Top-down parsing will not start. It will directly say the sentence is incorrect. It does not explore the subtrees that don't fit a valid tree. If it is an invalid tree, it is not going to explore. So we are not wasting the computation in case of top-down parsing. But the cons are we are not able to make the trees if the inputs are not exactly matching. May not be terminating in case of recursive rule because there's lots of recursive rule matching, so it is computationally expensive, you can say, and it may redrive the subtrees as the part of search. So these all are the pros and cons for the top-down approach. We can have then bottom-up. For the bottom-up, again we have some pros and some cons. So in case of bottom-up, because we start from the word level and we'll go up to the sentence level. So this will not explore the tree that don't match the input. So we are starting with the word level. So first for every word we should have there should be a rule defined, and there's no recursion here, so it is less problematic rather than the top-down approach. This is useful for the incrementational or the fragment parsing. And as a demerit of this method, it explores the subtree that will not fit full input. So maybe we may be starting with some word and it's not going to make this. It is possible that for all the word will not be accommodated in my tree. So that's a con for the bottom up search. So that's all about top down and the bottom up approach. If you like my video, please hit the like button. And if you have any query, you can write in comment box. I'm happy to answer your queries. Thank you very much.